Hello again, this is the course of data structure and algorithms, and in this video we are going to learn about the new concept which is priority queue. So if you already learned about the data structures of queue, I guess you understand what is queue, but there is another way to design the data structure using what we call as the priority queue. And I'm going to explain what is priority queue, and this is the basic concept of the priority queue, and the slides was taken from the book Data Structure and Algorithms in Python. And yeah, I'm going to explain the first part, which is about the priority queue ADD, and I will explain also about the sequence-based priority queue and the priority queue sorting. So what is priority queue? Okay, so in the priority queue, yeah, you know, if you are in your daily life, you will have your priority. Maybe when you have your time is very limited, okay, you will do something which is more important for you. So the same with this kind of priority queues, we are trying to get the important things, and we will put it the important things as the priority. Okay. So the priority queue is a data structure to store a collection of items. Okay, so we are going to save or store a collection of items, and each item is a pair. And you need to understand about the key and value. If you already know about the data in Python, there is one data structure which is the dictionary. Okay, so in the dictionary you have also key and value. The same with this priority queue, we have the key and value, but we have different process, or we have different methods for this priority queue. So we have two main methods, which is add and remove min. And we, okay, yeah, we have add. It means I'm going to add k. K, it means a key k, and the value x. And if you are going to remove, okay, so it means I want to remove and return the item with the smallest key. So the priority, it will be depending on the key values. So we assume that the key is an integer value. This is from the small number until the highest number, for example. And there will be additional methods like minimum. We want to return what is the smallest key, and then we want to know the length of the priority queue, and we want to know whether it is empty or not. So some application is about the standby flyers. So if you have the flyers, and then what is the uh, flyers that you want to distribute. For example, you have the flyers about food, and you have flyers about jewelry. So those two different flyers you need to distribute to the anybody who pass by the pedestrians. And yeah, you need to know, okay, this guy may want to eat this food. Maybe for this lady they want to know the jewelry, then you can just give the jewelry flyers to the lady, and you just give the flyer food to the person, the a guy, for example. And you can also do with this action, auctions, okay, sorry. So you know auctions. Yeah. So when you are in the market, and then let's say someone wants to give the highest bid, the highest price, then of course the bidder will give the person who wants to give the higher price, who wants to pay higher price, who he will get the product, for example. So it is also important when you do the auctions in the online place. Okay, so in the online place, you, of course, the priority will go to the highest price. Okay. Stock market is also the same thing. So it's yeah, it's related with the priority queue. So as long as you have the numbers to indicate the key, then there will be a kind of priority queue. For example, yeah, so we have this P. Okay, so as P is uh, starting with empty. Okay, So we start with the empty priority queue, and then we have one method which is add 5 comma a. So we have the priority queue which is a key a5, and then the value is a, and then I want to add 9. Okay, 9, and the value is c. So in this priority queue, I assume that the higher number represent the less priority. So the smallest number represent the higher priority. So if I put 9c, it means this c is not that priority. So I can put on the next. Then I can just put 9 and c. Remember, when we have key and value, there should be no similar, no, there should be no the same value for the key. So there might be no the same 5. Okay, might be no the same 9. And then now I have another at 3 comma p. So I need to put the 3 because 3 is smaller than 5 and 9. Then it is in the first, or it is the priority. Okay. And then I have the 7 d, and 7 is in between 5 and 9. Then I can put in between. Okay, so it's not that priority, but yeah, it's not the end, or it's not the last one. Then I can put in between 5 and 9. So if I want to check what is the minimum, then I will get the 3 and b. And if I want to remove the minimum, it means I want to uh, exclude the minimum value or the first queue, and then maybe you still remember with the queue data structure, we want to dequeue. Okay? So we want to dequeue the 3b, and then of course it will be removed from the priority queue. If I want to remove another minimum, then of course I will remove the 5a. Now the length remaining 2. Okay, and we have another remove min 7d, and then I have another remove min, then I have 9c. So the things in the priority key now it becomes empty. So if I ask the p is empty, yes, it is true. If I want to remove the minimum, then it is error because there is no value in the priority queue. So we need to understand the concept of the total order relation. Okay, so the concept of total order relation in priority queue, it will be a very important function because we are going to check the key. Okay. So keys in priority queue can be arbitrary objects on which an order is defined. So the key, if you see the example before, it will have the number 1, 2, 3, and so on. But in other kind of application, the key might be arbitrary objects. Okay. So it can be A, B, C, D, or it can be A1, A2, A3, and so on. Okay. So two distinct entries in the priority queue can have the same key. Oh, okay. So if you have the same key, then you need to understand what should you do for the object with the same key. So in the mathematical concept, we understand there is one concept about the total order relation. So the total order relation can be applied in the key selection, okay, or key placement. So the total order relation for the mathematical of the priority queue we can have first is the reflexive properties. So the reflexive properties means the x should be less than or equal to x. What does it mean? So it means reflexive properties. So if you have one key, then of course the key is less than or equal than the key itself. The other property is the antisymmetric properties. So the antisymmetric properties means if the x is less than y and y is less than x, then I can just imply that the x equals to y. Okay, of course you can understand this one. Okay, x is less than y and y is less than x, then of course x equals to y. And there should be transitive properties. If x is less than y and x is less than z, no, sorry, y less than z, then I can say that x is less than or equal to z. Okay, so this kind of mathematical concept for the total order relation, it will determine the order. Okay, so I want to check how can I determine the order if I want to order this on the ascending. So if I want to start with 1, 2, 3, then you need to have this mathematical concept for total order relation. So there should be no other numbers that will be in the same values. So we have the composition decision pattern. It means the item in the priority queue, it will be a key value pair. And priority queues store items to allow for efficient insertion and removal based on the keys. Okay, so if you have the keys, it will be easier for you to insert and remove, because in the previous examples, if we have 7, for example, then we can just insert in between 5 and 9. Okay. So in the priority queue in the Python files, okay, we will have one more class, which is item. And the item, it is a kind of slot. Okay? It contains of key and value. So when you create an object, then there should be key and value, and there should be one function to check whether the key is less than the other key. Okay? And of course, you need to check if it is empty or not. So we already have the additional methods for the priority queue. Now, if we want to understand the implementation of the priority queue, we can see this kind of idea. Okay, so if we want to use the priority queue for a sequence, okay? So you have a sequence, and then you want to do something related with this priority queue. What is the priority? Okay, if I go back to the example before, the priority will be the smallest one. Then there will be two ways. Okay, there will be two ways. First, if you want to input the object first with unsorted list. So it means when you have an object, just insert. When you have another object, just insert. When you have another object, just insert. You have another object, just insert. You have another object, just insert. And after you have this one, you want to sort it. So sorting is another way. So sorting is another method. Of course, yeah, it will have some computational issues. If you're just adding without if it is on an unsorted list, then the add function will take all one time, since we can insert the item at the beginning or at the end of the sequence. Okay, so if you want to add add add, then it's easy. Okay, especially if you want to add like the queue, so you want to add the object at the end of the list. So every time you have a new, then you will add on the at the end, at the end, at the end. So if we want to remove the minimum and we want to check the minimum, it will take O(n) time, since we have to traverse the entire sequence to find the smallest key. Okay, so this is the worst case. Okay, if you can understand the binary search tree, maybe it will be easier. So it will take log n. Okay. But the other way, we can sort first. Okay, so whenever you have an object, then you will do the sorting. So for example, if I have the first object is 4, okay, then I will just keep the 4, okay, and then if I have another object which is 5, then yeah, I will just do this kind of sequence. Okay, I have 4 and 5, then finish. Now if I have another object which is 2, what happened? Then if I want to implement a sorted list, I will reshuffle. Okay, so I will reshuffle. It means I will check 5 and 2, which is lesser. Oh, okay, 2. Then I just change to 2 and 5. And then 2, I will check 2 and 4. Okay, so 2 and 4, which is lesser? So of course 2. Then yeah, I need to change to 2 and then 4 and then 5. Okay, so after I have this one, yeah, I can do the add. So I need to add again. So if I add 3, what happened? Oh, if I add 3, yeah, it depends on the number. So it depends on your process whether you want to put in the, okay, if you are using stack, of course the element will be at the first one. Okay, last in, first out. If you use the queue, it means the first in, first out. Okay, so it depends on that one. If I use it, so if I want to add one object to the priority queue, it will take on, because every time I will do checking for every element and then sorting. I will do the checking and then sorting. Okay, so like this one. So I need to sort the element like this one, and yeah, of course it will take until n times. It depends on the number of items. Okay, so we have another method like remove min and minimum. And yeah, after you already know the minimum value, or after you sorting, it will be easier for you. So you will know that the number one or the key number one will be in front. Then yeah, of course, you when you want to remove the minimum, you don't need to count for every element. So it will take one. Okay, since the smallest key is at the beginning. So there will be two kind of implementation. Okay, so you can use the unsort priority queue. So the unsort priority queue means this is the priority queue without sorting. Whenever you have your new add, okay, whenever you have new add, and then you will add at the last one. Okay, if you are using the sorted priority queue, so whenever you add the value, then you need to do sorting. So the sorting means, yeah, if you want to check the last data with the first data, so it means you want to walk. Okay, so in this case, yeah, we in the book they use walk to indicate that you want to sort from one element to the last. The other is the same, like minimum and remove. Yeah, so it's the same, but for this minimum and remove minimum, then it will need to find the minimum. Okay, so to find the minimum, it will take n times. Okay, now when we have the key, okay, so you know that, yeah, we have two ways. We want to unsort, it means you just insert the object, and then if you want to find the minimum, you do sorting. Or you want to work for the first time, you want to sorting the first time, and then whenever you want to remove the minimum, then you will just take the minimum. So we can use a priority queue to sort a set of comparable elements. So first is to insert the elements one by one with a series of add operation, and then remove the elements in sorted order with a series of remove min operation. Okay. So the running time of this sorting method depending on the priority queue implementation. So I explained before. Okay. So if you are using the unsorted, then you will have O1 for inserting the element, and then you will have ON for finding the minimum. So in this case, if I want to do the sorting, okay, so I have the S and C. So the output will be a sequence S with sorted element in increasing order according to the C. So C is something, yeah, something you want to, for example, ascending or descending. Okay, so this one. Now P is the priority queue with comparator C. Okay, so if it is like lower than equal to 2 or greater than equal to Okay, so it depends on that comparator. Then while S is empty, and then we have the negation. So if S is not empty, then we want to remove the first. What is remove first? So I would like to remove the first element into E and then put into the P. Okay, so I will put into the P and the element A, and then with the object which is, we call this is the null or no values. Okay, and yeah, we will do until all S is empty. Okay, and then after we have an empty S, we will check the P. So the P will be the, if P is not empty, because we are adding the P here, if P is not empty, then we can remove the minimum and the key of E, and then we can add the last. So maybe it's easier for you to understand with the example here. This one. Or maybe before we do the example, I would like to mention that the selection sort is the variation of the PQ or the priority queue sort, where the priority queue is implemented with an unsorted sequence. So what is the unsorted sequence? So we have the unsorted list. The idea is the same. So we can do with this kind of selection sort. So the running time of the selection sort, it will have the on, okay, on times for the insert. For the insert operation, we will have on, and removing the element in sorted order for the priority queue with n, the movement operation will take, yeah, on as well. So all the things will take like n power 2. What does it do? Let's see. I have the sequence 7, 4, 8, 2, 5, 3, 9. Okay. If you are using the sorting, then you will have the you will put the sequence into a priority queue, and the priority queue will be something like, just a list like this one. And then you need to put, so in order to have the priority queue, then you need to sort it first, right? Yeah, because we are using the sort, and I want to select. So the selection sort means I want to sort, and then I can select some values. For example, I want to remove the minimum, then you can easily just select the first one because you are already sorting the elements. So we have the 7 for 8 to, and then I would like to get the first one. So the first one is 7. Okay, so I can just put I will remove from S, and then I put in the Q P, sorry, and then I remove the 4, and then I put in the priority queue. Okay, so something missing, so it should be here. Okay, 7 and 4, and then so and so on until we have 7, 4, 8, 2, 5, 3, 9. Why I need to put this one? Yeah, this one will take on. Okay, after we have the on, then I will need to return back. And then how can I return back here? How to return back is to check the minimum first. Okay, so 7, 4, 8, 5, 3, 9. I need to check the minimum, which is 2. Then I will put 2 into the first one. And then I need to, so this is the same with the idea, this one. So P is empty, is not if it is not empty, then remove the minimum from P, and then just get the key, and then S at last E. So it means you want to put the S at the last one. And then next is we still have this one, this list. And then we will check minimum. So the minimum will be 3. So the 3 will be added in the last. So we have the remaining elements like this one. So the next smallest is 4. Then 4 will be added into the S, and so on until we finish all the elements in the P, so we can have a new element S. Sorry, we have a new sequence S, and the result has been sorted, and then we can select the minimum. For example, we can select 2, which is the minimum. There's another way to use the pure priority queue sort. So we call it the insertion sort. So it is the sorting sequence or sorted sequence. So before I give you the example about the sorted list, okay? So the idea is the same with the sorted list, but the name is using the insertion sort. So in this insertion sort, we will first inserting the elements into the priority queue with n insert operations. So the insert operation will take n times, okay, 1 plus 2 plus 2 until n times, and then removing the element in the sorted order for the priority queue is with a series of n remove in and remove minimum, it will take n time. So you will do with the n for 1, and then you will do the insertion sort, then it will take for n power of 2. This is the example if you are using the insertion sort. The idea is the same. You have the S, okay, this is the sequence, and then you want to make the priority queue. What is the priority queue? In this case, yeah, I remove the minimum, yeah, remove the remove the first. Okay. I will remove the first is 7, and then after I have this 7, I will like to check what is the next one. 4. Okay, 4, because I know that 4 is the next one, I will check 7 with and 4. Which one is lower? Oh, okay, I know that 4 is lower than 7. Then just put 4 in front of 7. And then I have 8. What happened to 8? So I need to check where is the location of 8. Because I know that now we have the priority key 4, 7. So 8 will be at the last one. Why? Because I need to compare 8 and 4, 8 and 7. So if we know that 8 is the highest number, then 8 will be at the last. And then I have 2, 5, 3, 9. So I would like to use 2. Then we have 2, 2. What about 2? Okay, if you compare with 4, okay, it is smaller. Then, yeah, 2 will be at the front. Then we have 5, 3, 9. So we have 5, 3, 9. It means I need to check the 5. So 5, no, 5 will check with 2, and then 5 will be checked with 4, and 5. Okay, we know that the location of 5 will be in the middle of this one, and so on. So after we have all the values sorted like this, then yeah, we can return back the result of this one into the S. So the return values will be only from the minimum, or yeah, 2, 3, 4, 5, 7, 8, 9. Then it will take n times. Okay. So this n time and plus this n time, so that's why it will take like n power of 2. Okay, the same with the previous one. With the selection sort is it is n power of 2. So the insertion sort, it means you want to insert every time you want to change to the priority queue. There's another way to do the sorting. We call it the in-place insertion sort. What is it, in-place insertion sort? So instead of using the external data structure, we can implement selection sort and insertion sort in place. So what does it mean? It is a portion of the input sequence itself serve as the priority queue. So let's say for in-place insertion sort, we keep sorted the initial portion of the sequence, and we can use swaps instead of modifying the sequence. So you don't need to use S and P, because yeah, maybe you think that, oh, why we need to use two variables? Yeah, that's one easy way to use two variables. So the P will be the priority queue and S will be the sequence. But if you don't want to have two variables, you can use one way, which is the sorting or swapping. Okay, so if I have 5, 4, 2, 3, 1, then I can just try to find the smallest value by swapping 5 and 4. I will. I think we know that 4 should be first, then it will be swapped. Okay, so this one will be swapped, and then after I swap, I will check 5 and 2. Okay, because 2 is smaller than 5, then it will be here, so it will swap. and then after I have 2 and then 2 we check with 4, then of course I know that 2 is less than 4, then swap. So the result will be 2, 4 and 5. Now I would like to check again 3 and 5. Okay, 3 and 5, of course 3 is less than 5, then swap. And then 3 again, in this part 3 we want to check with 4, so 3 is less than 4, swap. Yeah, so we can get 2, 3, 4, 5. So we have 1. Okay, what is 1? 1 is less than what? 5. Okay, 1 is less than 4. Yes. 1 is less than 3. Yes. 1 is less than 2. Yes. Then 1 will be in the first position, and the remaining will follow. So we can have 1, 2, 3, 4, 5, like this one. Okay, so this insertion sort, you can use it without adding a new variable like p. So just use the s, for example. We have the sequence s, then we can just in place do the in place insertion sort. So it will make more efficient. But yeah, it depends on your idea. If you want to add a new variable, that's also fine. If you want to use the in place insertion, it's also fine. The operation time is the same, o n power of 2. Okay, so we have this one. I at this state I will not explain the Python file, so you can just take a look on the Python file that I put on the Google Drive. So because basically I will just share the ADD, the abstract type, and if you can use it for your project, that will be good. Or yeah, maybe you will try to get other uh, ADD. Yeah, that also fine. Okay, so you may have some clues later when you already define your problems for your project. Okay, so I guess that's all for the video of the priority queue, and I will continue with other video with other related topics. Thank you very much for listening.